Welcome to BeyondBIM. I'm thrilled to present to you today's episode where I speak with Dr. Michael Grieves, also the pioneer of the well-known terminology that we commonly refer to as digital twins. Although in the early days, this was more commonly referred to as product lifecycle management, from which he then coined the term and the concept digital twin. Michael's focus has always been on virtual product development, engineering, systems engineering, complex systems, manufacturing, and especially additive manufacturing. Dr. Greaves has also authored the seminal books on PLM, Product Lifecycle Management, and Virtually Perfect, Driving Innovative and Lean Products Through PLM. In my discussion with him, he guides us through the early days of working with NASA, Boeing, and General Motors on realizing the concept of a digital twin. Michael's path into academia is not traditional in the sense that he has over 4 decades of extensive executive and deep technical experience in both global and entrepreneurial technology and manufacturing companies. Currently, Michael works at the Florida Institute of Technology in Melbourne, Florida, where he helped form the Center for Advanced Manufacturing and Innovative Design. He is also the Chief Scientist of Advanced Manufacturing and Executive Vice President, Operations at Florida Tech. In my discussion, Michael reminds us that great and impactful research comes from patience and often takes decades to come into real fruition. We're always keen to learn more about the thoughts and suggestions of our listeners, so if you have any suggested topics or speakers that you would want to hear on BeyondBIM, please drop us a comment on our next episode. And now, let's take a listen to what Michael has to say about digital twins, its origins, and its future. First off, could you just start by telling us a little bit more about yourself and what led you to your research into PLM and digital twins in the first place?
Yeah, that's sort of an interesting and long journey, but kind of the shorter version of it is that I have been in the computer industry all my life. I was lucky enough to basically get involved with mainframes when I was in high school, before anybody even knew what they were. And sort of spent my life in the computer and manufacturing industry. In fact, started my own business before I was 30. But by the time I was in my late 40s, I decided I had enough fun playing with the accountants and attorneys, and I had taken my company public. And I decided I went back to go back to school, and I went back and got my doctorate from Case Western University in Cleveland, Ohio. And my focus, my interest was in the fact that information was basically a replacement for wasted physical resources, not for the resources we need to do something, but all the other things that we do that make mistakes. And so I started working on it. And if you know anything, what you do about doctoral programs, you want to get through your doctorate, not do your new work there. So once I had gotten my doctorate from Case Western, I was looking at the idea of the fact that in information, we now were rapidly approaching the point in computerization where we basically could have the information about something, and in point of fact, it was as rich a representation, or could be as rich a representation, as having the actual product itself. And so the whole idea was the fact that we could now move from a functional centric version of looking at the product where we, designed the product and threw it over the wall to manufacturing, and they kind of tried to build it, and then they threw it to the poor people that had to service it, that we could basically take this functional centric view and turn it into a product centric view. And that's the premise behind product lifecycle management. And so this idea that I could have a virtual representation of product and move work into the virtual world that I formerly had to do in the physical world, what was the genesis of both product lifecycle management and the digital twin. And in point of fact, my early presentation, I think in 2002 or 2003, the model didn't even have a name. It had 3 major components. It had the physical product itself, it had the virtual product, and it had the connection between the two. But it was basically was the concept for product lifecycle management. Fortunately or unfortunately, I was a little ahead of the curve in terms of what the computer capability could do. And I was working with NASA from 2006 on. And my colleague at NASA, John Vickers, used it in a 2010 NASA roadmap and coined the term digital twin for this conceptual basis of a virtual product that you could do work with. That kind of went sort of unnoticed until about 2015 when there was an Economist article about a short thing from GE Look Ahead that defined what the digital twin is. And from that point in time, I think that you've seen an explosion. As I always like to say is in 2015, if you had done a search on digital twin, you would have come up with some of my stuff. By today, you get 1 million hits. So it's really exploded on the scene.
That's fascinating. And a lot of the articles that you now come across talk about digital twins and its origins, and they do, in fact, refer back to NASA. And even as back as I believe they quote the Apollo 11 mission as well. So was that kind of part of the vision when you were working with NASA, that this was something that has already been in existence for such a long time?
Yeah, that's a little bit misleading because at that point in time, you really didn't have a digital twin. You had sort of a physical representation of it, a model. So the idea that you would have twins was certainly NASA, but the idea that those twins could be information was not necessarily the concept that we've been working with. But from a NASA perspective is sort of once you launch the product, you lose track of it completely. I mean, you can't go send a repairman up 20 miles to fix something, so you better have a virtual representation of it. So it was a logical thing to do in terms of working with NASA to basically be having the information about the product so that you could do things with it, modeling and simulation, because literally you could not be in physical proximity to that rocket or space station or whatever you want to do. So the short answer to your question is no and yes. I mean, certainly the idea of twins comes from that, but the idea of digital twins is really kind of the work that we've done since 2006.
And you also authored the book titled Product Lifecycle Management. What was the original incentive to create that book, and how has the research and industry evolved in that domain since its first publication?
Yeah, well, that's the seminal book on product lifecycle management. And it was this idea that, first of all, that we could have a virtual representation of the product that could exist across the product lifecycle. And therefore, we could move from a very functional-centric perspective where engineering and manufacturing and operations as a support were completely divorced from each other and had their own information about the product, which was often inconsistent and incompatible, to this idea that we should be able to look at a product-centric perspective and add, basically consume and populate the information about the product so everybody was using the same information throughout the life cycle of the product itself. So it came out of that idea that said we now could basically sort of strip the information off of a product and have it exist in its own right without having to be in physical proximity to understand what the geometry of that product was, what the behavior aspects of it were. We basically could have all the information about the product without actually being in physical proximity to the product itself.
And is this always in the context of manufacturing per se for the assembly line, or is it also something that could potentially span outside of that domain?
So actually, it really was not related to manufacturing to begin with. It was really related to the physical products like rocket ships or airplanes or automobiles. And only when we started to look at the physical representations of factories did we basically sort of apply it to it. In fact, one of the most common papers was a paper that I did for Apriso Corporation, which is now part of Dassault Systems, that basically talked about the digital twin in use in the factory. But really, we had started off on the idea that said, if we were going to create a product itself, we needed to have consistency and ability to track the product across its entire product lifecycle. It happens to work for manufacturing because of the fact for two things. One is manufacturing equipment are merely somebody else's products, so you can have digital twins of it and control the factory from virtual representation of it. So one of the things I first said is we're going to look at having factory replication. There's a reason that factories are built with the foreman's shop overlooking the floor so he could see what's going on. But we said, what if you could do that virtually, that anybody, anywhere who had the authority could basically see what was going on in that factory? The second thing is in order to create a digital twin of a specific product, we need to collect that information as the factory is manufacturing it. So the factory is basically a huge source of information about what I call the digital twin instance. Think of it as a serial numbered version of a particular product. So in design, a product may have a tolerance of plus or minus 0.05. When I actually go build it, it doesn't have a tolerance anymore. It has a specific number of what actually was made that I can measure. So capturing that information for individual products is critical. It started off in engineering itself, PLM did, but it was clear that it needed to move to manufacturing quite quickly.
So what you just mentioned there about the instance, so a digital twin instance, is that in any way tied to the concept of what we now have recently heard of, which is the digital thread? So something that's kind of almost akin to a log or a history of that physical asset and the digital twin itself.
Yeah, so maybe I should tell you what the digital twin types are, because the digital twin encompasses the entire product lifecycle. So the digital twin prototype, or the prototypical digital twin, is basically all the designs that I can make. So when I'm designing it, I basically design all the ones that I can make. When I actually go make something, that's a digital twin instance, and that are the individual things I did make. And then finally, I have a digital twin aggregate, which was all the things I did make, and I basically can collect that information to basically get behavioral statistics. What the digital thread actually is the communications that ties the various aspects of the product lifecycle through. So for example, when I design the product, now when I go to make it, I need to have information from my design side to know what processes I need to apply, what tolerances that I can have, and that comes via the connection with the digital thread. So if you look at my model where I have the physical product, the virtual product, and then the connection between the two of them, the connection between the two of them is really the digital thread.
So is that somehow akin to when we talk about digital twins communicating with one another, or is that what you meant by the term digital thread in this instance?
The digital thread is, so for example, if I have an airplane flying around and I'm not in physical possession of it, and it is transmitting its performance back to its digital twin, that digital thread is what is the connection there. So,
right.
So it's basically a digital twin connecting to its physical counterpart. It's also basically digital twins from various aspects of the product lifecycle, using that information throughout the entire history so that I know that this particular product did these particular things, and I have that history. So the digital thread ties the virtual to the physical version, and it also ties the different digital twins from the various parts of the product lifecycle. So, and I divide that into create, build, operate, sustain, and dispose. So I never want to lose that information because that's valuable information for me to have. And that's why I said when we've turned from a functional perspective of engineering having their own information and manufacturing having their own information, basically this allows me to use that information across the entire product lifecycle.
So recently there's been obviously a lot of discussion by governments, researchers, and technology providers alike on the use of digital twins. Now, you did already describe what a digital twin is, but for instance, if I am a novice and I really don't understand what is it in the context of manufacturing, how would you describe it?
Basically, it is all the information that I need in order to make decisions about what I should do. So what I want to do, I always drive my digital twins from use cases. So how am I going to create value? So for example, in the manufacturing phase, if, for example, I have a robot that malfunctions and delays for a few seconds, I want to be able to have that reflected in my digital twin and then project ahead in my digital twin to say, in an hour, I'm going to have a bottleneck because that's delayed one assembly line that has to meet up with another assembly line. So it's basically what information am I going to have that allows me to fix things before they occur. And in point of fact, it's the difference between the digital twin and Industry 4.0 is Industry 4.0 is about how can I decrease the amount of time between I have a problem and I fix it. With the digital twin, what I want to do is predict that I'm going to have a problem and fix it before it ever occurs. So the digital twin is extremely important in the manufacturing format, as I said, for two reasons. One is for managing the factory itself, but secondly is for basically collecting the information that I'll need for the products that manufacturing plant is putting out.
That's interesting. So from what you've just explained, a core component seems to be, in part, the ability to gather insight or to learn from previous experiences. I take it this pairs very nicely with the other future trajectory, and that is with the use of AI and machine learning.
Yeah, so in fact, I've got a chapter that I'm doing right now called the Intelligent Digital Twin, which is about using AI. But as importantly, my contention is if we put AI into products themselves and allow them to make decisions, we better have a digital twin so that we know what they're doing. And so I think there's sort of two pieces to this, that AI will certainly help in terms of the digital twin making predictions, doing machine learning, and basically being able to adjust itself to the new behavioral aspects that it needs for its environment. But it also gives us insight into what that product is doing, so that if we don't do that, my contention is that we are in the situation of having basically cascading catastrophic problems, and that we won't know that they're occurring because we won't have any visibility into it. So I propose a digital twin for what I call overwatch capabilities of products where we actually put AI into them.
So it sort of gives us a bit more transparency as to why or how those decisions are being made.
Yeah, I mean, I think it gives us transparency into it. Without that, I don't know, other than doing postmortems and trying to figure out what happened, that you would be able to understand why the AI did what it did. So in this particular case, what we're doing is basically saying, look, at the digital twin is a representation of the AI system, so we will know what parameters it changed, that at a minimum we'll know what happened, but ideally we can basically intervene before they do something that we will sorely regret that they did.
Just a note to say thank you to all of our current followers and subscribers via LinkedIn. BeyondBIM has now, out of popular request, also published its own YouTube channel, where all of our episodes are now available. Please click subscribe if you'd like to stay up to date on our latest content via YouTube as well. And the term itself of a digital twin has now scaled even beyond just single products or in a manufacturing setting. And we are seeing talks of national citywide digital twins and even talks of business level digital twins. Now, based on all of your experience and what you've witnessed to date, do you think that this is feasible, that we can scale that concept beyond just the product itself? Can we have a digital twin of a process or of, let's say, at a business level operations side?
That's a really good question. And intentionally, I have thought you could do this all along, but I have basically stuck to things that have geometry just because I thought that would start to confuse people. But all along, I felt that if you can sort of visualize something, there's no reason why you can't have a digital twin of an IT system, of logistics, of a management system. So the geometry, while it has been sort of integral to my view of the digital twin, really isn't necessary if I basically can say, look, I can visualize, for example, here are these objects and here's the information moving between these objects, and here's the information that I want to collect in order to create value. There's no reason why that can't be done. As opposed to, as it relates to cities, systems of systems are clearly an ability to involve digital twins. And in fact, in the chapter I'm working on, I contend that it's going to be a requirement because of the complexity of those sorts of systems are certainly beyond what humans can basically look at. I can look at a simple system and know what it's going to do. I look at a complicated or in fact complex system like a city and something that occurs in one part of it can have cascading and huge issues in other parts of the city. So, the butterfly effect of a butterfly spreading its wings somewhere and causing a hurricane somewhere else. We're not at that scale, but certainly you're going to have sort of scale increase effects in terms of systems. And so I think that the digital twins of system cities, airports, those are going to be a requirement for us to basically manage those systems appropriately.
I can actually imagine on the back of what you just said with regards to cascading effects that given the current situation that we face ourselves in, have you noticed that this has now in turn created an even increased demand for digital twins?
Yeah, I think there's a couple pieces to it. One is simply an evolution of understanding and having success, so you want to do additional things. The second aspect is that the advances in computerization, Moore's law in particular, but it impacts not only computing processing, but memory and communications and storage. As we get exponential increases in those capabilities, we can basically do more and more. So things that were compute bound, a few years ago are now capable of being done that we previously couldn't do. So modeling and simulation has gotten much more robust and even granular because we have the computing capabilities to do that. So I think there's a couple of different reasons why that is, and certainly it is. We need to manage more things better. We have more complexity in systems, but we have more computing capability to deal with them, and we have had more success in terms of doing the sorts of things that we use digital twins for in a more rudimentary fashion.
And obviously, the digital twin will also have an impact on how those businesses operate. Have you noticed in your work how manufacturing businesses have changed over recent years, and has that helped enable digital twinning?
I think digital twinning has enabled us to get better in the manufacturing area and collect information off the factory floor from the various machines. At one point in time, machines were completely independent, and even if they had intelligence, it was localized. And now the ability of collecting that information and looking at it across the entire factory and aggregating that information is allowing us to do things like predict machine failures, predict bottlenecks or inefficiencies, improve quality of products by adjusting downstream processes from understanding, what we exactly made. So I think that has enabled us to do a better job. And obviously Industry 4.0 has raised the attention of, we need to have IIoT, Industrial Internet of Things, to allow these things to communicate and give us information. But what do we do with it? And the answer is that we ought to basically be driving that into a digital twin of the factory itself.
I'm assuming that the realization of digital twins is not without its challenges. Can you talk a little bit more about what those challenges look like at the moment?
The issue of it is that sometimes you're compute bound, and what you want to do, you just don't have enough computing power to get that done. And so that's one issue. The other issue is basically, collecting what I say is massive amounts of data and no information. So you have people who are fascinated with data and collect it, but they can't do anything with it. So they spend cycles in creating systems that really add no value. And then simply understanding the system itself is sometimes problematic in knowing what your system components are so that you can basically have a twin of them that's understandable and actually does recreate what's happening in the physical space. As I always like to say, the physical world trumps the virtual world every day of the week. So you got to make sure that your modeling and simulation really reflects what's happening out there. Sometimes, people try to boil the ocean and generally come up short in terms of trying to do too much. So as I say, my focus is pick valuable use cases that are going to basically create real value for your organization, and then build upon those, as opposed to trying to basically create the perfect digital twin out of the chute.
And with regards to finding value for businesses that are now making that investment into digital twins, have you come across discussion about how this might potentially change how the business itself operate? Is there opportunities whereby, let's say, in some instances, consumer-facing services might make use of digital twins, or let's say customer interaction with the product can somehow improve the customer experience of that product or service?
Yeah, I think there's lots of opportunities there, and as I mentioned, de-siloing, so that, for example, engineers are not designing products that really don't do what the consumer wants, and so my definition of quality is very different from most people, in that it's only a quality product if it actually performs for the users to their expectations. So one of the opportunities is to collect the information about how the consumer is actually using the product and feeding that back to design staff so that they understand exactly what they should be designing in terms of capabilities of that product so that it does do what the customers are looking for. Creating that feedback loop between what are the customers doing with the product and how is it performing in use, and feeding that back into the organization, I think has a huge opportunity to increasing the value of the product for the customer.
And do you think that we've reached a stage where, let's say, the OEMs are finally going to agree to sharing of that data within the entirety of the digital twin? Let's take a product or an entire building, for instance, which consists of numerous components from various different OEMs. Are we at a stage where these OEMs are ready to share and aggregate that information for the benefit of all of the engineers?
If I knew that answer, I'd probably go into the future prediction business.
Yeah.
But the issue there is that it is a social issue as opposed to a technology issue. Could they do it right now? Absolutely. Do they want to do it? Well, I think that really sort of started me on this whole product lifecycle management. Was the idea at the point in time that I had done in the early 2000s was these exchanges where basically the OEMs would take advantage of their suppliers by doing reverse auctions. And I said, gee, if we could only share the information, everybody could win, because that was a win-lose proposition. So It hasn't happened since the early 2000s. I don't know if I've got a lot of optimism that it will happen now, but I can say that if the OEMs see value in basically sharing that information, then they probably will. But I think there are some cultural barriers that are going to have to change before that occurs. I would like to see that happen, but I don't know whether it will or how fast it will.
And if you were to quote, let's say, a success story of a digital twin, where would that be? In what sector?
The one that I've used for years is in the airplane engine business, where basically they censor their airplane engines, and they collect statistics on every one of them that are flying, and they're able to basically take that information, and when they see certain sensor readings, predict that there's going to be a failure for a component downstream. And so they fix the problem, when the plane goes through its next maintenance thing, as opposed to having it break while it's sitting on the ground, or even worse, when it's in the air. So I've used that as sort of the poster child, but I'm seeing it in all cases, in oil and gas and automotive, and certainly in space systems. But the ability of being able to correlate potential faults and predict failure that can be repaired before it actually occurs is, I think, pretty widespread in what organizations are looking at. And I think it's occurring in pretty much every organization that I talk to.
And for aspiring researchers or practitioners that are entering this field and this domain, what advice would you give to them when choosing or trying to make an impact in research and in their careers?
So there's a couple interesting pieces of that, and that is, don't get too impatient. Ideas, the digital twin concept was created in the early 2000s and really didn't come into fruition until the latter part of the second decade. So patience is an important aspect. The second thing is that, look for things that are going to, in essence, change the paradigm. So a lot of research is done what I call, puzzles at the margin. And basically it's solving little particular puzzles. Paradigm shifts are very difficult to look at, but when they occur, they're major research opportunities. So look for, things that are going to happen that can result in a paradigm shift, as opposed to, nibbling at the margins of a particular problem. But that takes, given sort of the tenure system and things like that, sometimes that's problematic, again, because I was sort of a non-traditional doctorate and had already sort of quasi-retired and failed miserably at it. I had the ability to do that. But again, if you pick an area, I think that sometimes you take a too myopic view of it, and there's a bigger opportunity that's outside the horizon of what you're looking at. So I would encourage people to look at, bigger problems and go after things that are going to make major differences in people's lives. But it's all about creating value. If it doesn't create value, it's just it's just working through numbers. And I think you need to look at what creates value in an organization.
So far, you have mentioned in our discussion that you're working on chapters. Can you give us a little bit more insight on what you're working on next, and where could our listeners find out more about your research work and its resources?
So with respect to the book and book chapters, I do have an Amazon authors page. And the easiest book to find is not the book you mentioned, but my second book, which was called Virtually Perfect. And that was a little play on words. But that book, if you go to that book, you can then click on my name for my authors page. You go to ResearchGate, which is basically a research website, and I have a lot of material out there in terms of the origin of the digital twin and some other material. The chapter I'm working on right now is for the AIAA Association, which is Astronautics and Aeronautics, and the title of that one is going to be the Intelligent Digital Twin and understanding what complex systems are with that.
Thank you for tuning in to listen to BeyondBIM podcast. If you enjoyed this episode and want to hear more from our latest episodes, then you can visit BeyondBIM, which is available on SoundCloud and iTunes and all the other major podcast providers.